Okay, so we are going to be recording this. Hopefully you guys already jotted this down in your notebooks, right? Number one, it's really rule one of exponents. And you know what? We don't even need to really know the number of the rules that we're talking about. You just need to know what the actual rule is, where when you're multiplying terms with the same base, you simply add the exponents. So if you look at number one, it really says 2 times x squared times y to the third times 3 times x to the fourth times y to the fifth. Because it's all pure multiplication, you could change the order. Everybody knows that 2 times 3, if you switch the order, 3 times 2, it's still 6. So you could change the order. So I'm going to choose to change the order and multiply the 2 with the 3. And 2 times 3, we're talking about numbers here, is 6, right? And then I am going to choose to multiply the x squared times the x to the fourth. And rule 1 says that when you're multiplying with the same base, you keep the base and you add the exponents. 2 plus 4 is 6. And last but not least, you have the y to the third and the y to the fifth. That'll give you a y to the eighth. Any questions on that straightforward rule 1 question? No? We're good? All right. Number two, we do have parentheses with an exponent on the outside. And this is technically rule 3 and 4. And again, who cares about the number of the rule? All you got to do is understand the truth that when you have parentheses with an exponent on the outside, you're going to distribute that outside exponent to each and every inside exponent. All right? So the number one mistake I see that students make is they say 3 and they put it right here. 3 times 2 is 6. Wrong. Okay? This is not the number 3. It is a number 3, but it's not a regular number 3. It's an exponent of 3. So you're going to take that exponent and distribute it from the outside of the parentheses to each inside exponent. And everything on the inside has an exponent. Even if you don't see it, it technically has an invisible 1 right there. So you're going to take that 3 and distribute it to the 1 and to the 2. And of course, a power to a power, you multiply. So in reality, you're going to get 2 to the third power and then x to the sixth power. And out of that answer, you could still do the 2 to the third. You'll get 2 times 2 times 2, which is 8. And the x to the sixth, you just rewrite it, and that's your final answer, 8x to the sixth. Got it? I hope so. Let's move on to something more fun. Well, actually, it's not more fun. It's just a different type of rule. Number 3. It's actually the same rule. Once again, we have parentheses with a power on the outside, an exponent on the outside. And whenever you have parentheses with an exponent on the outside, what do? Anybody? Distribute, right? Keyword distribute. You distribute the outside exponent to each and every inside exponent. So first, let's understand that everything on the inside has an exponent. The 6 has an exponent of 1. The 7 has an exponent of 1. The W has an exponent of 5. P has the exponent of 6. R has the exponent of 3. So we're going to distribute this outside exponent to each and every inside exponent. So let's distribute this outside exponent of 2 to each inside exponent. You're going to say 2 times 1 is 2. So you're going to have 6 squared. 2 times 5 is 10. So you're going to have W to the 10th. 2 times 1 on the 7 is 2. So you're going to have 7 squared. 2 times 6, the power of 6 on the P, that's 12, so you're going to have P to the 12th, and 2 times 3 is 6, so you're going to have R to the 6th. That's your answer, but the only other thing that you could do is actually simplify 6 squared, which is 6 times 6, and simplify 7 squared, which is 7 times 7, to give you your final answer, 36 W to the 10th over 49 P to the 12th, R to the 6th. So that's your final answer there. How about this one? Copy this one down. We have 2x to the negative 3. It's one rule and one rule only. And that rule is, anybody? What rule are we going to apply here? And forget about the number. Just tell me what pops out at you.
Rule 5.
Okay, rule 5, which is what? Anything with a negative exponent gets moved to the other side and becomes positive. Okay? So, does the number 2 have a negative exponent? No, it actually has a positive 1 up there. The x is the only thing that has a negative exponent. So this is what I want to see everybody do. Circle it. draw an arrow to the other side. The other side of what? The other side of the fraction. You might be thinking, there is no fraction. Yeah, there is. Check it out. Just put a fraction bar right there, and now it's a fraction. That x to the negative 3, it moves down, and it becomes x to the positive 3. So if you moved it down and you change the sign, you can now cross it out up on top. It's no longer up there. And there's your answer. 2 on top over x to the 3 on the bottom. You see, it's easy. Moving on. Number 5, copy that down. That's a different rule. That's the latest one that we learned. What rule are we going to apply right here? Anybody? Canceling out rule, right? Whenever you have like 5 divided by 5, that equals 1. 10 divided by 10, that equals 1. A divided by A equals 1, right? So the reality is you have A's on top and on bottom, but there's 4 of them up on top and only 1 of them on the bottom. So one of these A's on the bottom completely cancels with one of the 4 up on top, leaving you 3 left over up on top. So your answer is A to the 3rd. No more A on the bottom. Same thing with the B's. There's 3 B's on the bottom, 6 B's up on top, right? 3 B's on the bottom, 6 B's up on top. All 3 B's completely cancel out with 3 of the 6. There's still 3 B's left over up on top. It really becomes like a subtraction problem. I like to think of it as canceling, right? In my mind, I know that there's 6 B's up here, B times B times B times B, 6 times, and there's 3 of them down here, B times B times B. 3 cancel with 3, there's going to be 3 left over up on top. So anyways, here's our answer, and we don't have to put A to the 3rd, B to the 3rd over 1. We don't have to. You could if you want, but in reality, anything divided by 1 is that same exact value. So A to the 3rd, B to the 3rd is your final best looking answer right there. Any questions? Yes. Go for it. Moving on. Copy this one down, please. I know what you're thinking. Man, this is getting fun. Absolutely. We have multiple rules to apply here. What rule pops up in your head when you look at this thing? Anybody? Any rule? Negative exponent rule, right? Okay, that's a good one. So wherever you have a negative exponent, you must grab it and move it to the other side, okay? Elimination methods also, or not elimination method, but the elimination rule, right? Where you could cancel things out. So like the u to the 5th and the u on the bottom, we could eliminate there. Not only that, we actually have numbers out here, like coefficients on numerator and denominator. So what does that mean? That's kind of like if you had the fraction negative 12 over 2. So let's start with the actual coefficients. Yeah, the numbers. What would negative 12 over 2 actually equal? Negative 6, right? You could think of it as negative 12 divided by 2, that's a negative 6. Or you could think of it as reducing by 2. 2 divided by 2 is 1. And 12 divided by negative 12 divided by 2 is negative 6. So we could think of it that way. Let me erase it here and actually do it up here on top. So 2 divided by 2 is 1. 12 divided by 2 is 6. So we're going to have a negative 6 up here instead of a negative 12. And we did say the canceling rule. So let's do that. There's 1 u down here at the bottom, and there's 5 u's up on top. So this one single u will cancel out with 1 of the 5, leaving you 4 left over up on top. And let's do the negative exponent rule. What does that mean? I'm going to take this t to the negative 1 and move it down. And I'm going to take this t to the negative 3 and move it up. So this is getting way too ugly right now. And also this x to the negative 4, we're going to move that down as well. So to save myself from making mistakes, I am going to start a new fraction and start writing what I have right now so far so I don't make any more mistakes. I have a negative 6 over 1. I'm going to keep it that same color so you could see it, negative 6 over 1. Then we move on to t to the negative 1 is going to move down, and t to the negative 3 is going to move up, and then they change signs, they become positive. So we're going to have a t to the positive 3 up on top, right? That t to the negative 3 moved up, it became t to the positive 3. T to the negative 1 moves down, and it becomes t to the positive 1. Okay? And then we have u to the 4th. up on top, because that 5 canceled 1 with 1, so there's only u to the 4th up on top, no more u's on the bottom. And this x to the 5th, it's still down here. I'm not going to mess with it yet. But this x to the negative 4, it moves down right next to the x, and it becomes x to the positive 4. So it looks like we have 2 more rules to apply. Anybody? What rule could I apply now with what I have so far? Yes?
Add the exponents to x.
Excellent. Add the exponents of the x's. Rule 1 says that if you're multiplying 2 terms with the same base, you could add the exponents. So yeah, x to the 5th times x to the 4th, that's really x to the 9th, and I could just scratch it out since I already have that answer right there, right? Is there anything else that I could do? Say again? Canceling, right? Canceling again, right? We canceled up here the u's, but now we have t's on top and bottom. So let's cancel those t's. We cancel one of those t's with one of these 3, leaving you 2 left over. So what do we have as a final answer? We have negative 6 t squared u to the 4th over x to the 9th. You could put the 1 if you want, but it's not necessary. There's your final answer. I hope you guys understand that. Heck yeah, it's getting more fun. Copy that down, please. We are going to be applying tons of rules here, right? And many times it doesn't matter which rule you apply first, but like, for example, you can't cancel out this k to the 3rd and that k to the 3rd because this k to the 3rd is inside parentheses. So you need to do something up here first before you could start canceling things out, right? So I see some parentheses with an exponent on the outside, and I know rules 3 and 4, forget about the numbers, the rule where you distribute that outside exponent to the inside exponents. So let's do that. Let's circle the negative 4 and put it by multiplying with the negative 1 right here and multiplying it with the 3 right there. So up on top, we have the j to the positive 4, because negative 1 times negative 4 is positive 4, and then k to the negative 12 over that j to the 3rd, k to the 3. Okay. So now that we got rid of the parentheses, now we could think about canceling. What could I cancel right now, as is? The j's, right? Do you know why I can't cancel out k's right now? Yeah, negative exponents, you got to bring it down, right? So again, we're using different rules. We are going to cancel out the j's. There's 3 j's on the bottom that cancel with 3 of the 4, leaving you 1 j left up on top. And this other k to the negative 12, that negative exponent, it must be moved to the other side. Or that negative exponent term needs to be moved to the other side, and you'll end up with a k to the positive 12 that you're multiplying by this k to the positive 3. So since I moved it down and made it positive, I'm going to put a line through it because I already moved it down and made it positive. And we now have rule 1 to apply, that when you're multiplying 2 terms with the same base, you add those exponents. So our final answer will be j to the 1, you don't have to put the 1 power, you could just put j up there, over k to the 15th. Why 15? Because you add 3 plus 12. When you're multiplying with the same base, add the exponents. And there is your answer for number 7. You guys want to do another? Heck yeah, this is fun. Okay, let's do it. Number 8. Copy that down, please. Okay, so listen up, guys. Yes, you could distribute the outside exponent to each and every inside exponent. But since we have parentheses, and most of the time parentheses tell us to zoom in and see if we can do anything in there, is there anything that we could do in there on the inside of the parentheses? Any rules that we could apply to make the inside of the parentheses smaller before actually distributing the outside exponent? Anybody? Anything we could do on the inside? You guys are so what pops out at you? We're going to cancel out x's, right? Because we have x's on top and on the bottom. So we have 3 x's on top that completely cancel with 3 of the 4, leaving you one x on the bottom. Okay. Could we cancel out y's? Yeah. Come on, people. Wake up. This one y on the bottom cancels out with one of these, leaving you one up on top. Okay? Could we cancel out this z with that z? No. Why not? That's a negative exponent. And what do you do with negative exponents? You grab them, move them to the other side. That's going to become a times z to the positive 2. So now it's no longer at the bottom, it's on the top. Are you with me? So up here we have z times z to the second. That's really a z to the 1 times z to the second. Rule 1 says I could actually add these exponents because I'm multiplying with the same base, add the exponents. So what am I really going to get right here up on top? Z to the third, right? So this is really z to the third. Now, I do admit it's getting ugly, so let's rewrite this thing. We are going to have parenthesis, fraction bar, 2 over 3. There's no more x's up on top. There's only an x on the bottom. So I put the 3x on the bottom. The y to the 1 is up on top, and you could just put a y. You don't have to put a y to the 1. And the z to the third is also up on top, so I write down z to the third. On the bottom, we had the 3, the x, and that's it. So this is our new simplified inside value of the parenthesis, and it is to the power of negative 2. And now at this point, we could distribute the negative 2 to each and every term. Put the negative 2 on the 2, put the negative 2 on the y, put the negative 2 on the z, put the negative 2 on the 3, put the negative 2 on the x. But that means that you're going to have all bunch of negative exponents, which means you're going to have to move every single term to the other side. So that could get ugly looking. So here's a little trick. If you ever have a fraction on the inside that has a negative exponent on the outside that you're about to distribute to every single term, this is what you could do. You could actually take the inside and flip the whole thing and then make that positive. Let me repeat that once again. If you were to distribute it to every single term, then everything would have negative exponents, which means you have to flip everything. So instead of distributing first, you could actually flip everything first and make that a positive. So that's what I'm going to do. I'm going to flip that down here, and I'm going to flip this up here, and you will have your new fraction 3x over 2yz to the third. And that power of negative 2 is now going to be a positive 2. If that confuses you, you don't have to do that. You could distribute it to each and every term, and you're going to have everything that's negative, and you have to flip everything to make it positive. So at this point, after you flipped the inside, you could now distribute that outside 2. Put the 2 on the 3 right there. That'll be 3 squared. Put the 2 on the x. That'll be x squared. Over, put the 2 on the 2. That'll be 2 squared. Put the 2 on the y. That'll be a y squared. Put the 2 on the 3. That'll be a z to the 9th, because you are multiplying when you have a power to a power. So the final answer will be 9x squared over 4y squared z to the 9th. I apologize. That got ugly. Get it? Any questions? Yes. We could have, yeah, that's a good question. Could we have flipped it right from the original because it's negative? Yeah, we could have taken this whole thing, written it on the bottom, that whole thing, written it on top, and made that a positive. Yeah, so that could have, you could have done that as well. Yeah. Alrighty, guys, that wraps up the practice questions that I wanted to go over today. As you can see, these last 3 questions that we did, they're pretty challenging. Hopefully you understood them. So let's work on the assignments that we have for this week that are due this week.